Hello everyone. This is going to be a relatively short lecture this week because we're just covering two topics which are relatively easy to understand. In fact, it should be quite easy for you to learn these. It'll just take a little bit of practice. But these are two of the most fundamental programming constructs that you're going to use, and they are crucial to solving pretty much any problems out there. So we're going to talk today about both conditionals and loops. So first, let's talk about conditionals. So let's try to understand what the idea is of a conditional. It's basically code that allows you to execute the code when some condition is true and not execute the code, or perhaps execute different code when that condition is not true. So here's an example from one of my favorite games. This is Paper Mario: A Thousand Year Door. And here we see that Mario is fighting an enemy. Mario has a green suit in this case, but there's Mario. And you can see up in the top left corner that Mario's health is only 2 out of 10. And there's a rule in this game. If Mario's health is 5 or below, it will play some kind of tension-creating, annoying music in the background, and it'll do what Mario is currently doing. It'll make him look really tired and worn out, like just as a kind of a reinforcement so that you know that he is injured. This is an example of conditional behavior. It's only going to happen if his HP, Mario's HP, is less than or equal to 5. So this is an example of how you could use that behavior. So what we might do is we might choose the sprite to display, or the animation to show, to be the tired looking Mario if Mario's HP is less than or equal to 5, and the regular Mario idle animation will play when Mario's HP is greater than 5. Okay, so it's an optionally executed block of code. When we see how this looks in Python, you're going to see that a lot of Python blocks of code look the same. They're basically just indented bits of code. And that's just to group it all together so that you know it's part of one block of code. So conditionals specifically have two parts. They have a condition, and then they have the block of code. If the condition evaluates to true, so remember we talked about expressions in the previous section where the expressions can return a Boolean value. So we had things like logic operators and comparison operators that returned Boolean values. We'll typically use these operators in conditional statements. If the result of the expression is true, then we execute the block of code. And if the result of the expression is false, then we do not execute the block. There can be one line of code in the block, or there can be many lines of code in the block. All right, so here's some examples in both Python and C++. I've tried to highlight the Python. Of course, that's what we're paying attention to in this class. But since a lot of you are also taking the programming workshop, I'll show the C++ for comparison, and it's probably something that you've seen already. So you can see in C++ we say if, and then we use round brackets around the condition, and then around the block of code we use curly brackets. In Python, we do not use curly brackets, and it's not required that we use brackets around the condition either. So even though this basically does the same thing that the C++ code does, one exception here is that the Python program will print small value with a new line at the end because it automatically adds a new line when you have a print statement. Whereas in C++ that's not true, so there's a slight difference there, but otherwise these programs are exactly the same. So the key differences here, we still use the keyword if, but the difference is that the condition doesn't have to have round brackets around it. Certainly can, because you can put round brackets around expressions in Python. And we don't use curly brackets. Instead, what we do is we use a colon at the end of the line. So you can see after it says value is less than 10, you can see there's a colon symbol. And the block of code is indented. Now, there's only one line of code in this case, but if you indent additional lines of code, those will be considered to be part of the body of the conditional statement, and they'll get executed only if the condition is true. They'll get skipped over if the condition is false. All right, another option, sometimes we want to execute code only when a condition is true and then do nothing when the condition is false, so the if statement is perfect for that. But other times we want to do one thing if the condition is true, and we want to do a different thing if the condition is false. So this is actually representative of the example that we just looked at, where I want to display the tired looking Mario if Mario's HP is less than or equal to some value, and I want to display a not tired looking Mario animation if the HP value is greater than some value. So very, very similar to this. So we only have one explicit condition here, and the condition is exactly the same. In fact, the first couple of lines of this program are basically the same. We have the same condition, but now we have an else statement as well. You can kind of think of the else statement as being an implicit condition. So it's sort of like the opposite condition of the condition that's mentioned in the if line. So we're saying if the value is strictly less than 10, then we print small, otherwise, and of course otherwise means if the value is greater than or equal to 10. And else, or otherwise, we want to print not small. So these are examples of mutually exclusive blocks of code. One of these two blocks of code is definitely going to execute, but not both of them. So it's not possible to create a situation where none of these blocks of code are executed, neither of the print statements happen, and it's also not possible to create a situation where both of these lines of code execute. You can sort of think of the else condition as picking up all the remaining cases. So if we have something like a complicated if condition where we say if value is less than 10 or value is greater than 100, then do something, then the else condition will be everything except for those cases. So it'll be the value is not less than 10 and the value is not greater than 100, meaning the value is between 10 and 100 inclusive. Okay, so they're always mutually exclusive, and you can count on that in your program. In fact, most programmers rely on that condition when they're writing their code. If you have more than just two possible outcomes, so it's not just one or the other, it's you want to have kind of different ranges, then you can have an if else if. In most programming languages, like in C++, we use the keyword else, and then also we repeat the word if. So we say else if. So if the value is less than 10, print small. Otherwise, if the value is less than 20, print medium. Now this also has an implicit condition, because I'm assuming if the second condition is true, that means the first condition wasn't true, because it only executes until it finds one of these cases that actually turns out to be true, because all of these ifs and else are all grouped together. And so if the first condition is not true, and the second condition is true, that means that it's less than 20, of course, because we explicitly state the condition, the value is less than 20, but it also implicitly means that the value is greater than or equal to 10, because we would never have gotten to this third line of code unless the value was not less than 10, because if it was less than 10, we would have executed the first block of code and printed out small. All right, so in this case, we still have an else. We don't need to have an else. We can just have an if and an else if. If we just want to handle those two cases, and any other cases we just want to do nothing, we can leave out the else condition. But let's just take a look at what the syntax looks like in Python. So in Python, we squash the two words together, else if. We say elif, and that takes a little getting used to. It can be kind of annoying. It has one big advantage, that it's not nearly as many characters, and so it doesn't offset the condition quite as far over as the if condition, so it's a little easier to understand, I think. You'll notice that after the elif, we have a condition and then a colon. After the else, we have a colon. The colon always means that what's about to follow this code is going to be an indented block of code. Now, in all three of the cases shown here, we just have one line of code in each of these blocks, but if we indent more code immediately after this code, we can add as many statements as we want to this block. Okay, so these are going to be mutually exclusive as well. So we've got three different cases. So the first case is when the value is less than 10. The second case is if the value is greater than or equal to 10, but less than 20. And then the third case is obviously neither one of those two previous cases are true, which we can simplify to just say that the value is greater than or equal to 20. Okay, so if the value is less than 10, we print small. If the value is 10 or greater, but less than 20, we print medium. And if the value is 20 or greater, we print large. Okay. There are actually some other conditionals that exist in many programming languages. One of them is called the switch statement. Python doesn't have a switch statement, so you'll probably learn about a switch statement in your programming workshop course. We can't learn it in this class because there simply isn't one in Python. Another type of conditional construct in programming languages is called the ternary operator. And the ternary operator, that's a pretty fancy word, but you probably have heard the word binary in the context that something that is binary has two possibilities. So like a binary operator, for example, is an operator that takes two operands. Like the plus operator is an example of a binary operator, because we have, x plus y, we have to have two operands for plus. And there are also unary operators that have one operand. And for example, the negative sign is an example of a unary operator, because we can say -7 and then 7 is its operand. We're literally taking the value 7 and we're negating it. Or you could say -x if you want to negate the value of a variable. A ternary operator is an operator that has three operands. Okay, so that's a little bit strange. And there's the reason why they can just call it the ternary operator is because there's only one such operator that takes three operands in most programming languages. And they have a very different style in C++ and Python. In C++, it's pretty standard. They use the same style in Java and C# and JavaScript and lots of other programming languages. And basically it looks like this. We say some expression that returns a Boolean. So in this case, if x is greater than y, kind of question mark to say we're asking a question. Is x greater than y? If it is, then the value of this expression right here is x. And if it's not, then the value of the expression is y. And this is kind of the standard, which some people who already know another programming language, when they learn Python, will kind of roll their eyes to find out that there is a slightly different syntax that's used in Python. But actually, one of the things I like about Python is that it's very readable. As far as a programming language goes, a lot of the code looks a lot like English statements, and so that makes it much easier to understand your program. I've been kind of revisiting the topic of code readability many times over. So let's look at what the Python code looks like. By the way, this is just an assignment statement here, and all I'm doing is assigning the variable maximum equal to the result of this expression. So this whole big thing here, x is greater than y, question mark x colon y, is going to be a value, right? It's either going to be whatever the x value is or whatever the y value is, depending on the result of that condition. Let's read it out in English how it works in Python. This is the exact same statement in Python. You don't have to declare a variable, but this is just a normal assignment statement. And we're just saying the maximum should be equal to x if x is greater than y. Otherwise, the maximum should be y. And so this reads a lot like an English statement, right? I'm saying the maximum is x if x is greater than y. Otherwise, it's y. And so this reads very close to like basically what the program is doing to decide, whereas this one over here is it's understandable syntax if you're very familiar with programming languages, but it's very difficult for you to kind of read this out as an English statement. So I kind of prefer this notation, but of course it kind of only works in programming languages like Python. So in programming languages where nice concise code is important, like C++ tends to use really small operators and so on. Python tends to use words instead, which add to the readability but require a little bit more typing. But then it would work with, this kind of style will work with Python and Ruby and languages like that. But languages like C++ and JavaScript tend to use the other notation because they tend to favor operator compactness. Conditionals, or if statements, are code blocks that allow you to execute code conditionally. In other words, code only executes when some condition is true. In this case, we have a small program that has a single conditional with only one statement that executes if the condition is true. So first we have a variable, Pokemon HP, which is set to 5. We have another variable, Pokemon name, set to Tepig. And the condition in this case is that Pokemon HP is less than 0. That condition is false. So the body of the if statement, the print statement that you can see being skipped over here, is not going to be executed. For the next example, I'm just going to change the program ever so slightly. In this case, the condition is going to be true, so we'll see what happens when the condition turns out to be true. So first we declare the Pokemon HP variable. In this case, it's set to -2, which is what makes the condition true. Then we declare Pokemon name, which is set to typing just like last time. And now we're going to check the condition Pokemon HP is less than 0, which in this case is true. So we execute this print statement inside the if statement. Finally, we print the statement after the if statement as we normally do. One important point here is that in Python, all of your code inside the if statement needs to be indented. And another thing that's really important is you should get used to sticking to one or the other, either tabs or spaces, and be consistent throughout your program. In fact, if you try to mix the two, the Python interpreter will complain and not allow you to execute that code. What if you want to execute one block of code when the condition is true, and you want to execute a different block of code when the condition is false? That's what the if-else statement is for in Python. So first here we declare a Pokemon type variable set to fire, and we set a move type variable also set to fire. And if the Pokemon type and the move type have the same value, so in this case it evaluates to true, then we execute the statement inside the if statement like we did with just the regular if statement. So in this case, move damage will be equal to 30 when this program executes. So here we have the same program again with only one change. The value of move type is now set to fighting. So now the two values are not equal, so the condition should be false. Let's see what happens. So first we declare the variable Pokemon type, set its value to fire. Then we declare move type, set its value to fighting. Now we check the condition, it evaluates to false. When the false is encountered, it's the condition, it's the code block in the else part of the program that executes. So in this situation, move damage will be set to 20 when this program executes. One more thing to note about an if-else statement is that the two code blocks themselves are mutually exclusive. Let's watch the two executions one more time to highlight this. So in this situation, when the Pokemon type is fire and the move type is fighting, the condition is false, and we set move damage to 20. Conversely, when Pokemon type and move type are both fire, the condition is true, and we set move damage to 30. We only execute one of these two statements whenever this program executes, regardless of the condition's value. So these two are considered mutually exclusive, and that's always the case with if-else statements. What if you have more than two possible conditions? Well, Python has an elif statement for that purpose. In this program here, you can see that we have three mutually exclusive conditions, just like we had two mutually exclusive conditions with the if-else statement. So in this one, we only have one variable, opponent type, which is set to fire. We check to see if the opponent type is equal to fire, which it is. So that evaluates to true, so we execute the code block, move damage equal 10. And here we have the same program again, except that the opponent type is set to water. So in this case, this is going to match the elif condition. Elif, by the way, is short for else if. So the opponent type is set to water. We check to see if the opponent type is equal to fire. Of course it's not. This evaluates to false. Then we check the elif condition next. They are checked in order, that's important. Opponent type is equal to water, so this evaluates to true, so we execute the move damage equal 30 statement. And then we skip over all the remaining code because these are mutually exclusive, and the program exits. Finally, we have the other possibility where neither the if statement or the elif statement's condition evaluates to true. So in this case, opponent type is grass, and it's not equal to fire or water. So first we declare the variable opponent type, set it to grass. Then we check to see if opponent type is equal to fire, which it's not. That evaluates to false. So we skip over move damage equals 10. Then we check to see if opponent type is equal to water. Again, it's not. So this evaluates to false, and we skip over the code for move damage. So it picks up the else statement. So we do execute the code move damage equals 20. So when we're finished, the move damage is equal to 20 in this case. You can add as many elifs as you want. If you have additional conditions to check, you can add more elif conditions in order to handle those situations. Okay, so now let's get into part 2 of the lecture, which is to talk about loops. So the fundamental concept here is I want to repeat something. I want to do the same thing over and over again. And so there's usually quite a few different types of loops in programming languages. And just like there were with conditionals, not all of them are supported in Python. We don't really need them all. Quite frankly, we just need one kind of conditional. The ternary operator is totally optional. And similarly for loops, we really only need while loops. But it does make your program a lot simpler if you also have for loops. So Python supports while loops and for loops. Some programming languages support while loops, for loops, and do while loops. But Python does not. There's no such thing as do while loops in the current iteration of Python. They aren't necessary. So for loops, let's look at another example from Paper Mario: The Thousand Year Door. I'm going to try to get you to try this game at some point in time. It's very fun. Anyway, so you can see in this case, Mario and Mario's partner Yoshi are fighting a boss. And Yoshi's using a move called Ground Pound. And you can see the instructions here saying repeatedly tap R. But what's going to happen in the program is when we do that, the R is going to build up this bar. And if we get past this threshold over here, then it's going to do repeated ground pounds on the enemy. So to play the animation, we're going to actually show, Yoshi going up and down in the y-axis. So we're going to move the sprite up and down, and we're going to change the frames of the animation to show like a falling animation when they're going down, and like a impact animation when they land on the enemy, and so on. But they're going to do that repeatedly, right? So depending on how much we fill up this bar, it could end up doing something like 6 ground pounds. And so we might want to go through the same animation, the same movement in the y-axis 6 times. Okay, and so a loop is a great way of doing that. I mean, yes, we could copy and paste the code to do that, just copy it 6 times. But that's problematic in a couple ways. Number one, it's very inefficient. We got a lot of duplicated code, which just makes our program much longer. But probably the worst thing is if I just duplicate code, what if I screwed up? Or what if I want to go back and make a change? What if I have a slightly different animation that has a few more frames, and I want to go back and change it? I now have to change it 6 times. And I'm only repeating 6 times here, which is actually quite low for a typical loop. Usually when we loop something like 100 or 1,000 or 1,000,000 times. So obviously copying and pasting the code is not really practical because any changes to it will need to be made many, many times. And that's very inefficient for our time. So using a loop is much more efficient. So let's talk about the first kind of loop, a while loop. And so a while loop looks a lot like an if statement, actually. So if we look down here, we can see an example of a Python while loop. And if we just replace the word while with if, we have a valid if statement. So in this case, it will say if x is less than 10, then print x, and then a space, and then the string is small. And we talked before about how if you have a print statement that has 2 things passed as arguments to it, it'll put a space in between them so that they don't just like squish together by default. You can override that behavior, by the way. In the demos, I'll talk about this concept. And then also in the body of this, it also increments the value of x. If you remember, this will take the current value of x, add 1 to it, and then take that new value, the new incremented value, and put it into the x variable. So that is kind of pointless to do in an if statement, but in a while loop, it actually makes sense because after we do these 2 lines of code, we go back up to the top and we check the condition again. If the condition is true again, we execute the body of the loop again. All right, so that's basically how a while loop works. One of the things you've got to watch out for with while loops is that you could end up having an infinite loop. And so what fixes that are 2 things. You have to have a condition that eventually is going to be false, because a false while condition is really the only way to exit this while loop right now. And something in the body is going to change that'll make that condition false. So right now, initially when we start, we set x equal to 0. So we know x is definitely less than 10. So we know it's going to execute the body of the loop at least one time. But then you can see in the body of the loop, we're increasing it by 1. If every iteration of the loop increases it by 1, it's going to keep on increasing until it's no longer less than 10. So eventually this loop will exit. So at a glance, I can tell that this is not an infinite loop. But imagine, for example, I accidentally screw up and I put something like, while x is greater than 0, let's say, and I set x equal to 0 or something like that. In that case, it's not greater than 0, so I never execute the body of the loop. That's an example of a logic error that we've talked about previously. Or another thing I could do is here leave this while loop exactly as it is, but I accidentally mess up. Instead of increasing x by 1, I decrease it by 1. Sometimes we do want to go downward in a sequence of numbers, and if I did that mistakenly, thinking that going down was the appropriate thing to do, you'll notice that x is getting smaller and smaller, and it's not really going to be greater than or equal to 10 at any point in time. Now, that's not strictly true, because actually internally variables are stored in memory, and that memory space is a fixed size, and there's only so many digits that we can store. And so as the number gets smaller and smaller into negatives, there actually is a time where it will roll over into the positive numbers. And so that has to do with overflow, and overflow is a real thing, but we're talking about numbers in the billions or trillions or even greater. So let's compare it to the while loop in C++. Again, just like the conditional, you have to have round brackets around the condition in a while loop in C++, but in Python you do not. We also don't use curly brackets around the body of the while loop. We use a colon and indentation to indicate which statements are part of the while loop. So if we didn't indent this second statement, this x equals x plus 1 was aligned to the same column here as the w in the word while, then the x equals x plus 1 wouldn't happen until after the loop exited. And in fact, that would never happen because we're never changing the value of x. So it's really important here that x equals x plus 1 is indented here, because now it's part of the body of the loop, and it contributes to this loop not being infinite. If you ever encounter an infinite loop, they're easy to recognize, because when you encounter the infinite loop, your program will just sort of sit there and pause forever. Like it's doing something, but it never actually finishes doing that something. So what you do in that case is you just hit Control C. Control C is basically how you stop the program executing. If you're using Visual Studio, down in the execution output area, you can just do Control C and that'll quit the program. And then you go back and look at your loop. You're going to look at two things. Number one, you're going to look at the condition of the loop, and then you're going to look at the variable that the condition is checking. Usually you're checking a variable value. In particular, you want to see how does that value get initialized. In this case, we're initializing it to 0. And how does it get updated inside the loop? If you're not updating it inside the loop, then the while loop can't possibly exit, because nothing is changing inside the loop. Something inside the loop has to change something about the condition so that eventually the condition will be false. So that's something you always have to keep in mind when you're writing a loop to avoid this kind of infinite loop. An infinite loop is not usually a useful construct. So while a while loop can actually represent any kind of repetitive behavior in a computer program, it's not the most convenient for all of the situations, so we also have a for loop. So a while loop, because of the way that it works, doesn't execute until this condition here is false. And as a result, and if you think about the English statement we're saying, while x is less than 10, execute these two lines of code. It kind of reads as an English statement in both of these programming languages. But I don't know necessarily, like I can obviously look at this code really carefully and figure out how many times this while loop is going to repeat, but it's not obvious from the while loop itself, just looking at the while loop line, how many times this is going to repeat. And in fact, a while loop doesn't need to know in advance. Like you as a programmer don't need to know how many times the while loop is going to repeat. A while loop will just exit whenever its condition is false. And so you can make a condition that's going to allow you to exit. And in fact, there's a common type of programming where you might do some approximation of some value. So let's say you want to approximate some value like the sine of x. And you have a function that can create an example value for the sign of x. And you test to see if it's close enough to the correct result. And if it is, then you can exit. If not, inside the body of the loop, what that algorithm does is it tries to get a little bit closer to the correct value. And as long as the body of the loop is bringing it closer and closer to the correct value, eventually the while loop will say, yep, that's close enough. I can quit now, and I've got an approximation that I think is at least as accurate. Okay, and there's an algorithm called the bisection method, which does exactly that. It's always trying to kind of look in the halfway point between what it guesses and the maximum or minimum answer. Anyway, so the while loop doesn't necessarily know how many times it's going to repeat. So if you have a situation where I'm not sure how many times we're going to need to repeat before this is true, then you use a while loop. If you do know how many times it's going to repeat, then you should use a for loop because it's actually significantly simpler. So a for loop usually follows kind of a predictable pattern. For example, you might be following a pattern in some numbers. So for example, you want to loop over the numbers 1, 2, 3, 4, 5, or 5, 4, 3, 2, 1. You can go up or down. You can also skip over some numbers. You can start and end at different numbers. You have total flexibility. This is one of the weird things about Python. Weird good, though, because a Python for loop is much easier to understand than a C++ for loop. A C++ for loop is kind of a standard thing. So a lot of programming languages use almost exactly the same notation for their for loops. They have a for loop, and inside some brackets, they have 3 separate parts. The first part initializes the value of some variable or maybe multiple variables, and that only happens once at the very beginning. The second part happens at the very beginning of each repetition of the loop. We're going to check to see if we want to execute the body, and we only do so if the body of the loop, if this is true right here, rather, if x is less than 10. So this serves a very similar purpose to the condition in a while loop. And then the third part is how do we update the variable? So if you saw in the previous pattern, it kind of works this exact way. Sorry about the airplane going by, very noisy. This pattern is basically the same as the while loop that we saw on the previous slide. This one just increases x by 1. And in C++, you can use x++ to do that, which is, I kind of missed that when I'm writing Python code. Anyway, so that's how a for loop works in most programming languages. And obviously, it's more beneficial for you to learn that syntax because there's so many other programming languages that will use it. But let's look at what syntax looks like in Python. So this does exactly the same thing, except for if you remember, the print function will automatically put a new line at the end, whereas C++ cout will not. In this case, kind of awkward, but I literally am just going to list all the x values in a list. So over here, we started at value 0. We go up to, but not including, value 10, and we go up by 1 each time. And that's really all that's happening here. We start at 0, we go up by 1 each time, and we stop before we get to the 10. So this is exactly the same number of iterations, and x will have the exact same number, the exact same values as we execute this code. But it is a little bit bizarre that we have to manually list all of these numbers. If you think about it, I want to repeat this loop 100 times or 1,000 times, it's going to get very tedious. So there is a built-in function called the range function. And you can think of the range function as producing a sequence of values, just like this list here. So we have this list contains the values between 0 and 9, and the range function is capable of producing a sequence of values 0 to 9 as well. So the range function, I'm going to talk a little bit more about it in detail in the demo, but the range function takes 3 arguments, and I'm only passing one of them here. One of the things you can do with functions in Python is you can make some arguments have default values, so you don't always have to supply them. And range is an example of that. It has 3 arguments. There's a starting value, an ending value, and an increment value. And the increment value by default is always +1, +1. That's the value we're going to go up by 1 by default. So if you don't specify an increment value, it's automatically going to go up, right? And the start value by default is always 0. So we don't have to specify the start value either. And that kind of explains why this loop does what it does. This loop does the exact same thing as the other loop. Range 10, I'm only supplying the end number here. So the start number is automatically 0. The increment is automatically 1. And so we're going to start at 0, and we're going to work our way up by 1 each time until we get to 10. And range has kind of the same quirk as this less than over here, in that even though the n number is 10, we don't include the number 10 in our output. Okay, so that's a little bit weird and takes some getting used to, but it's consistent in Python. There's a lot of situations in Python where we start at a certain number and we end at a certain number, and we include the starting number, but we don't include the ending number. So in this case, this says, starting at 0, going up by 1, all the way up to, but not including 10, include all of the numbers that match that condition. So it'll be 0 through 9. And this is obviously much easier. And if I want to repeat 100 times, I can just put range 100. If I want to repeat 1,000,000 times, I can just say range 1,000,000. So this is actually a really, really simple way of doing it. One of the things I want to highlight, even though we are going to talk about lists and things later, I want to point out that range actually doesn't return a list. Okay, so this up here is a list. We're using square brackets here, and I'm looping over this list. In fact, all the time when you're looping over something called a sequence. And sequences basically are all the data types that we're going to do in next week's lecture. Basically, a list is an example of one. It's a thing that you can go through one element at a time. There's a certain ordering to the values, and there's usually multiple values. So things like strings and lists are examples of sequences. So this range does generate a sequence, and so therefore the for loop can loop over it. For loops can loop over anything that's a sequence. They can loop over strings, in which case they loop over each of the characters in the strings, and they can loop over lists, in which case they loop over all of the values in that list, whether it's a list of numbers or a list of something else. If they loop over a list of lists, then we'll loop over the lists that are in that list of lists. And we can also loop over other types of sequences, like dictionaries and tuples. So it's capable of looping over anything that's iterable. And a range is slightly different than a list. Okay, it's going to be a sequence of numbers, and it'll contain the exact same numbers as the loop above does, 0 through 9. But it's not a list, because a list is kind of pre-generated. So imagine I want to loop 1,000,000 times. To create a list, I have to actually create a 1,000,000 element list, and then I loop over it, which is really kind of pointless in this case. What range actually does is it creates something called a generator, which is going to generate the values in the sequence one at a time. So range is going to produce the value 0 first, then it's going to produce the value 1 if I ask for another value, and then if I go on to the next value, it'll say, yep, the next value is 2, and then 3, and then 4, and then so on until it gets to 9, and then after that, I won't have any more values. So it basically behaves exactly the same as a list, but it is more efficient. I don't like, if in the case of range 10, it's not such a big deal. There's only 10 values in that sequence, but imagine I did something like range 1,000,000 or range 1,000,000,000. It's actually very costly to create a list with 1,000,000 or 1,000,000,000 elements. In fact, you might not have enough memory to create a list with 1,000,000,000 elements in it. All right, anyway. So a for loop is very useful if you know how many times you want to iterate. Because you can see down here, it's really as simple as me saying, I want to repeat 10 times. So for x in range 10 is always going to repeat 10 times. And you have to really look at the C++ loop over here to realize that. Like, you have to think about it for a while. It's going to be 0, yes, 1, yes, 2, yes. You can count it on your fingers up to 10, but not including 10. So that's a total of 10 numbers, 0 through 9. Over here, it's much easier because if you just use range bracket 10, it's saying 10 times. There's going to be 10 numbers in that 0 through 9. So it's much easier to do just repeat a certain number of times kind of loop in Python. Just generally, Python loops are simpler. So one of the important things to remember about loops is you always have to have an exit condition. It's not really necessary to worry about this in a Python for loop. In a C++ for loop, you still do have to worry about it, because if you go back to the C++ for loop, there's the exit condition right there, and we have to make sure eventually that's going to be satisfied. It is possible to create a C++ for loop that's infinite. But in Python, it's much more challenging to do that. I'm not saying it's impossible, because you can iterate over a whole bunch of different types of things with a for loop. You could make something that's infinite if you wanted to. You can make a generator that generates an infinite series of numbers, so therefore your for loop will be infinite, but it's much harder to do by accident. So in for loops, they have a predictable, often finite number of iterations. So it's really important to pay attention to your exit conditions. This slide is just meant to highlight that. So you look at the exit condition, or you look at it's called the continue condition here, the while condition is x is less than 10. That's what is, if it's true, I want to execute the body of the loop. The opposite condition is the exit condition, right? If x is greater than or equal to 10, then I don't want to execute the body of the loop. I want to go on to the code that immediately follows the while loop. In other words, the code that's not indented. So that's the exit condition, and it takes some scrutiny. You have to actually look at the code to make sure that eventually it's going to be true. The exit condition is going to be true so that the while loop eventually exits. All right. A lot of infinite loops come from the fact that students haven't evaluated this, and they need to make sure that their exit condition is eventually true. In other words, their continue condition, their while loop condition, eventually becomes false. A loop is used when you want to execute code more than one time. Python actually supports two different types of loops. There's a for loop and a while loop. In this section, we're going to talk about the for loop. Now, a for loop can operate on anything that's iterable, which is just a fancy way of saying anything that you can go over one component at a time. So shown in this example right here is a string. So we can actually iterate over that string, the characters in that string one at a time. Now, if you look at the for loop syntax, you'll see that it says for variable in, and then in this case, a string or anything that's iterable like a list or a dictionary or whatever in there. X is a variable that doesn't exist in this program until now. So what's going to happen is Python will take the first character of the string A and put it into the X variable. Then it will execute the body of the loop, which, just like with the if statement, it is indented. So you can see here it's just a simple print statement. The print statement will print the value of the X variable. And then the loop will go back up to the top. So normally the code just executes from top to bottom. But in this case, with a for loop, we do return back up to the top of the loop. And we grab the next value. So in this case, the next character in the string is a B. So let's watch the execution of this loop. So in this case, you have a string delineated by single quotes. The first character of that string gets inserted into a variable. That variable X is a string type variable as well. And then we're going to print, X is equal to that A character. Then we go to the next character in the string, B. The variable is X now contains B, and then the variable X contains C. We print X equals C, and so on for D. We print X equals D. You can see that the value of the variable in memory is changing from A to B to C to D to E. Finally, when the string is done, there are no more characters left in the string. We execute the code that immediately follows the for loop. Here's a slightly more complicated for loop that shows a different type of thing that you can iterate over. In this case, I'm iterating over a list. So we have a list of numbers 0, 1, 2, 3, 4. And what's going to happen in this case is quite similar to what happens with the string. Instead of the characters of the string being placed into the variable, which in this case is called index, it's the elements of the list. So 0 is going to be put into index on the first iteration, then 1 would be put into index on the second iteration, and so on. All right, so let's watch what happens here. So the first thing we do is we declare a variable called sum of nums. And this is because we're going to add up all of these numbers together as the primary function of this loop. So that's going to create a new variable called sum of nums, which is an int type, initialized to 0. The for loop is going to create a variable called index, which is going to be initialized to the first value in the list, 0. Then we're going to print hello there, 0. Then we're going to add that 0 to the sum of nums, which is still going to be 0. Then index is equal to 1. We say hello there, 1. And then we add 1 to the sum of nums, making the sum of nums now equal to 1. Then we put 2 in the index variable. We say hello there, 2. And then we add that 2 to the sum of nums, making sum of nums equal to 3. Then we take the 3 and put that into the index variable. We print out hello there 3. And then we add that 3 to the sum of nums, making the total up to 6. Then we put 4 into index. We say hello there 4. And then we add that 4 to sum of nums, making the total 10. Now that the list has been exhausted, there are no more elements in the list. We now execute the code that follows the for loop. You can see in this case, I have 2 lines of code that are actually a part of the body of the loop. So the indentation that's shown here indicates what's part of the loop and what is not. One more quick comment before we move on. In a for loop, instead of looping over a list of integers, 0, 1, 2, 3, 4, we could actually use the range function to generate an iterable structure that contains those same values. So in the demo, I'm going to talk about how you can use this range function in more detail, but this makes this code a little bit simpler, especially if you have a really long list of numbers to iterate over. This is a way of generating that really efficiently. The second type of loop supported by Python is called a while loop. Whereas with a for loop, you iterate over an existing data structure that has a finite number of elements in it. With a while loop, you can actually iterate a different number of times, depending on what the condition is. They're especially useful if you don't know how many times you want to repeat the code. So in this example here, we're going to simulate a battle. And so we're going to be generating some random numbers. Of course, I've pre-chosen the random numbers here to demonstrate, but we can see how this while loop here could execute different numbers of times depending on what those random numbers ended up being. So let's walk through this program. So in this case, just want to point out that I'm using a library called the random library. And I'm using this from random import rand range because there's a function called rand range, which imports a range of numbers. A range of integers, and I'm using it down here to generate a range, an integer within the range 20 to 35. Okay, and this might be something you would typically use in a battle for determining damage if the damage wasn't a constant. Okay, so this program first generates a variable called RHP, and that's presumably the health points of our Pokemon. And another variable called opponent HP, which is the health points of the opponent Pokemon that we're battling. So those two variables are going to be added to the variable table and initialized to 60. And you notice that the while loop here has a condition that gets checked before we even execute the body of the loop the first time. So just like with the if statement, we have an indented block of code, and with the for loop as well. Here, and the indented block is what's going to be part of the body of the loop. So if this condition is true, we execute the body of the loop. And it's possible that inside the body of the loop, we're changing something so that the condition may be different. So we continually check that condition every iteration of the loop. So we're going to check see if this condition is true right now. So you can see that the condition is our HP is greater than 0, and opponent HP is greater than 0. And we can see from the variable table here that both of those two conditions are true. So let's walk through this program a little bit slower here. So those both evaluate to true and true. And remember, when you have an and keyword, true and true evaluates to true. Because this condition is true, we're going to execute the body of this loop. So the first thing that we do is we generate a random number. And we happen to generate the random number 31. So we're going to subtract this from the opponent's HP. This simulates our move. So our Pokemon did a move, and we did a 31 points of damage. So this is going to change the opponent HP value. So we can see that changes to 29. Then we're going to check to make sure that the opponent Pokemon is still conscious. And so we check to see if the opponent HP is greater than 0. It is. So that evaluates to true. So we're going to execute the body of the if statement, just like we did back in the previous video. And now we're going to adjust our own Pokemon's HP based on some random number. So first we're going to generate some random number between 20 and 35. We generate 26, and we're going to subtract 26 from the value of our HP, giving us 34. Okay, so now we go back up to the beginning of the while loop again, and we check to make sure that the condition is still true. So we can see that our HP is equal to 34, therefore it's greater than 0, and opponent HP is equal to 29, and therefore it is also greater than 0. So both of these two conditions here are still true. So we end up having a condition of true and true, which of course evaluates to true still. So we're going to generate another random number. In this case, we're going to generate the random number 30. So we're going to subtract 30 from the opponent's HP. So that's going to be 29 minus 30, giving us -1. Now, because the opponent's HP is not greater than 0, this if statement condition here fails. So we don't execute the body of this if statement, and therefore we never adjust our HP. So we go back up to the beginning of the loop, getting a little ahead of myself here, and evaluate the condition again. So now in this case, our HP is 34, that's greater than 0, but opponent HP is -1, which is not greater than 0. So this evaluates to true and false, which is false. So then the code after the while loop starts to execute, and these two lines of code print out the opponent and our own Pokemon's HP. I'm using a strange syntax here that we haven't seen just yet, using the curly brackets inside the F string here with an equal sign after the variable name. We'll actually print out our HP equals and then the value of our HP, which is something that you typically do when you're debugging your program. So we'll talk about some more advanced techniques for debugging your program, but this is a great way to do it in a really basic way. If all you want to do is just make sure that the value was calculated correctly, then you can do that. So just for completeness, I'm going to do another run through of the same loop again, but this time with different random numbers so that we can see how this might result in different behavior because we have random numbers. It could also mean that we do a different number of iterations of the loop. So in this case, we're going to do the exact same process. The code is exactly the same, but because of the non-deterministic nature of generating random numbers, it's going to behave a little differently this time. So we initialize our HP to 60. We also initialize opponent HP to 60. Then we check these two conditions. They both evaluate to true. So we execute the body of the loop. We generate a random number, in this case 22. That ends up giving opponent HP 38. Opponent HP is still greater than 0, so we do execute the body of this if statement here. So we generate 31 points of damage on our Pokemon, giving us an HP value of 29. Both of these two values are still greater than 0. So we're going to execute the body of the loop again. So we generate another random number for opponent HP's damage. That generates 21 for a total of 17 now. The opponent HP is still greater than 0. So we also generate a random number for our HP. In this case, 29 gives us an HP value of 0. So now our HP is not greater than 0. Even though opponent HP is greater than 0. So now we end up with while false and true, which evaluates to false. So the loop exits. Whenever the condition is false, the loop exits. That's why the condition is often called the continue condition. And the reason why we use the keyword while is because as long as the condition is true, I want to execute this code, or while this condition is true, I'd like to execute the code that's in the body. So now it'll print out our HP and opponent HP at the end. All right, so you can probably imagine why these are so important. A lot of algorithms that are out there involve you doing things sometimes one way and sometimes another way. So for example, I might want to search through a binary tree. A binary tree is a tree that has two directions at every intersection point. So I can go left or I can go right. So you can probably imagine I'm going to need a conditional sometimes, because sometimes as I'm going down the tree, I want to go to the right side, and sometimes I'm going to want to go to the left side. And obviously loops as well, you're going to often have repeated behaviors. So an example, looking through a list for a particular number, I might want to check to see, is it the first element? Nope. Is it the second element? Nope. I want to keep looping through all of the elements of the list until I either find the thing that I'm looking for, or I get to the end of the list and I know that it's not there. So conditionals and loops are really, really fundamental and very important, just as important as variables and values and types from last time for solving problems. And it's kind of weird, but we've actually covered the most crucial parts of programming languages already, and now you can actually solve a lot of problems out there. A lot of the other programming constructs that we're about to learn about are actually just conveniences. So things like functions and classes and stuff like that can make your program a lot better structured and make your code more reusable, but they're not critical. You could write your code without them. And some other things are mainly shortcuts. So things like regular expressions are just a shortcut for doing something kind of a long way, looking for patterns, for example, and looking for patterns in a string. And if we see that pattern, we might want to do something. For example, we look at something, it looks like an email address. Then we might say, hey, that's a good email address. And if it's not, we might say, can you enter your email address again? You've made a mistake. That kind of thing is just a convenience. We could do that using just loops and conditionals, but the conveniences are what make our job a little bit more tolerable. So we're going to definitely cover those constructs anyway. But I just want to point out that basically we've learned everything we need to know in order to start problem solving. And that's in fact what I suggest you do. So this is a relatively short lecture. And so what I would suggest that you do is do some practicing. Try out some problems. There are lots of sources of problems out there. One of my favorites is called Project Euler. Project EULER. So if you do a Google search for that, it'll take you to a website that has a whole bunch of math problems that you can solve in any programming language. And all you have to do is write a program to find the answer, and then you paste the answer into the page, and it'll tell you if you're right or wrong. And some of the ones at the beginning of that project are very easy. Like there's something like 800 problems, so you probably never get through the entire list. But it has some, at the very beginning, some relatively straightforward problems that you could implement. There's also LeetCode and Coding Bad and so on. There are a bunch of websites that have some practical problems to solve, and they range in difficulty. So just try to pick something that's relatively straightforward at the very beginning. And again, there are some exercises in the ebook that you could also take a look at. All right, so that's it for today. I'll see you next time when we'll introduce a slightly more advanced programming topic. See you later.